Alright, welcome back to Scholar's Drive, doing some algebra. Today we'll be working with graphing radical equations, because they're radical. But anyways, all functions are transformations of their parent functions. That says transformations, because I write poorly. Radical functions contain a radical such as y equals square root of x. See? Radical. That's the square root symbol. And y equals cube root of x. Because that's what we'll be graphing. Parent function of a square root. So we have a function. Here is the parent function. Most basic square root function. And then we have the most basic cubed root function. Okay. So let's graph these. When you're graphing square roots or you're graphing cube roots, use perfect squares for square roots. This is for your x values, by the way. Use perfect cubes for x. And, well, what's perfect squares, perfect cubes? Well, it's basically the same thing, because I'm going to put in 0, and square root of 0 is 0, and then put in the square root of 1. Sorry. 0, 0. So perfect squares is 1 squared equals 1, 2 squared equals 4. So for your x value, you're going to plug in 1 for 2 cubed is 8, and then 16. Because, sorry. Okay. Let's redo that. 1 squared is 1, 2 squared is 4, 3 squared is 9. 9. And 4 squared is 16. So I'm going to use 0, 1, 4, 9, 16. And I don't use any negative numbers because we can't have negative square roots, otherwise we go imaginary, and that's a different type of graph. So, plug in these into the equation. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Boom. Graph. 0, 0. Easy. 1, 1. Hopefully that's easy too. 4, 2. So we count along the x. 4, up 2, and then over 9, 3, and then blast off into 16. Anyways, so we got this going on. It's like a little curve going on. Okay? Some people could say it's like a sideways half of a U, but it's not. Or maybe it is. It's not. Anyways, use perfect cubes for x cubed. So we have 1 cubed, which is 1. 2 cubed, which is 8. 3 cubed, which is, what? 27. But you know what? Since this can go negative, I'm just going to use negative 8, negative 1, 0, 1, and positive 8. Because those are perfect cubes, and they can go negative. Cube root of negative 8 is 2, negative 2. Cube root of negative 1 is negative 1. Cube root of 0 is 0. Cube root of 1 is 1. Cube root of 8 is 2. So we got this going on. 0, 0, 1, 1, negative 1, 1, and then 2, 8, or 8, 2, and negative 8, 2. Got that going on. Let's look at domain and range for these. Domain. X is greater or equal to 0. Can't be less than 0. Range. Y is greater or equal to 0. Because the square root of any number can't be negative. So let's just write that. Square root can't be negative. Okay, let's look at the x cubed domain. All real numbers. If you want to know the actual way we would do this, we say x belongs, that means belongs, to all real numbers. So it means that x belongs to the set of all real numbers. That means x can be, yeah, okay. And then y belongs to all real numbers. X, they're general forms. So all square root graphs look like this, and all cube root graphs look like this. Where A, like everything else, the vertical stretch or shrink. Same here. So I'm just going to put that vertical stretch or shrink. The H, horizontal shift. Same. Same. And then K, vertical shift. Okay, and if you don't remember this, vertical stretch or shrink means fat, skinny. Vertical stretching looks like it's skinny, and then vertical shrinking looks like it's fat. Horizontal shift, move left or right. Vertical shift, move up and down. Okay, let's move on to actually graphing these. Boom, identify the index of the radical. So this is, part A is square roots, part B cubed roots, part C square roots, part D cubed roots. Yeah, we get the idea. Okay, and then all graphs are shaped like their parent function. Identify H and K, plot the first point, make a table, find the other points. Ba-da-ba-da. Okay, here we go. This is how we do it. So, all that's happening in this graph is we have y equals 1/2 square root of x. So we just have a vertical stretch or shrink. In this case, it's a shrinkage because a value is less than 1. And we're going to use the same points. So 0, 1, 4, 9, and 16. Okay. So we do square root of 0 is 0, 1/2 of 0 is 0, 1/2 of 1 is 1/2, square root of 4 is 2, and 1/2 of 2 is 1, square root of 9 is 3, and then we get 3 halves, and then 16, square root of 16 is 4, and half of 4 is 2. Our domain and range, x is still greater or equal to 0, and y is greater or equal, or y is, yeah, y is greater or equal to 0. Yep. Plot our points. 0, 0, 1, 1/2, 4, 1, 9, 3 halves, so 1.5. You got this going on. Okay, part B. So remember so we have this going on. X minus h plus k. Okay, so it's a horizontal shift h, and we take the opposite of that number, so it's a going to the right 4. Okay, so that's where we're going to start. We're going to start at 4 and get 0, and then we plug in -4 because we know this is a cubed root, and then we're going to do, let's say, 3 and 0, or 3 and 5, sorry. Can't use 0. Well, I mean, we can use 0, but so you kind of guess what points that you need. So since we started with 4, 0, we choose a number above 4, which is 5, below 4, 3, and then the opposite of our original number. So negative 4, I plug that in. Negative 4 minus 4 is negative 8. Cube root of negative 8 is 2. 2 times 2, or 2 times negative 2 is negative 4. If I plug in 3, I get negative 2. Plug in 5, I get 2. And what do you know? It looks like this. So 4, 0, 5, 2, 3, negative 2, negative 4, 4. And we know what the graph generally looks like. It looks like something like that. Okay. Okay, part C. No horizontal shift. We have a vertical shift of up 2. And then we are multiplying everything by negative 4. So 0, 1, 4, 9. Plug in 0, I get 2. Plug in 1, I get negative 4 plus 2, which is negative 2. I got negative 6, negative 10. Okay. So 2, remember negative reflects the graph, okay? That's why this is going to open up down or start going down. So 0, 2, start up here. And then 1, negative 2, 4, negative 6, and then 9, negative 10. That is a vertical stretch. Okay. So we had our original graph that looks like this. So what's happening is it's being reflected over. It's opening up wider, faster, and it was just moved up. Okay, part D. Horizontal shift of left to down, or left to up 3. That one, left 2, down 3. Okay, so we're going to start at negative 2, negative 3. Boom. Okay. And so I'm going to try negative 3 here. And negative 1. Okay. So how you pick your cube roots is, remember, you're just using powers, your cube powers. So let's review again. 1 cubed is 1, 2 cubed is 8. Okay. So I'm going to take my x value. So I started with negative 2, negative 3. I'm going to add 1 to it, both sides. And then I'm going to add 8 to both sides of negative 2. So this is negative 10 and 6. Okay. And the reason why I do that is because those will make it easier for me to figure out, when I plug it in, it'll be make it easier for me to figure out the numbers. So for example, I added 1 to both sides because negative 3 plus 2 is negative 1, and the cube root of negative 1 is negative 1. That was easy. And then let's continue. Negative 1 times negative 1 is 1 minus 3 is negative 2. Okay, and then another example, I plug in negative 10. Negative 10 plus 2, or let's try 6. 6 plus 2 is 8. Cube root of 8 is 2. So that makes it easier. So negative 1 comes out to be negative 4. Negative 10 comes out to be negative 1. And 6 comes out to be negative 5. I recommend rearranging these and putting them in order so it's easier to graph. But this is how it goes. So we have negative 2, comma, negative 3, negative 3, negative 2, And then we have negative 10, negative 1. And then we have negative 1, negative 4, and then 6, negative 5. Yep. So you got that going on. So this is square roots. We're starting off at 5, 6, so I'm going to put that in the middle. Actually, no. I can start off with 5, 6. So 5, negative 6. And remember, 1 squared is 1, 2 squared is 4, 3 squared is 9. Okay? So what I'm going to do is add 1 to my x, and then add 4 to my original x. Okay. This should be 14. Okay. So I plug 6 into the equation. 6 minus 5 is 1. Square root of 1 is 1. Times 3 is 3. Minus 6 is negative 3. If I plug in 9, I get 9 minus 5, square root of 4 is 2. Times 3 is 6. 6 minus 6 is 0. 14 minus 5 is 9. Square root of 9 is 3. 3 times 3 is 9. Minus 6 is 3. Okay. So at 5, negative 6. Six, negative 3. 9, 0. Okay. So we're starting here, and it's looking like that. Okay. Oh, sorry, I forgot to do domain and range and all these. Part B, what's going on? Oh, this is still all real numbers. I think all the cube root ones will have all real numbers. They will. And then part C. What was I doing? Oh yeah, for domain, x is still greater or equal to 0. And then my range, y is less than or equal to 2. Yep. Because the highest point on there is 2. Here, domain, x is greater or equal to 5. Because we're starting at 5. And then y is starting at negative 6. Alright, last one, and then we'll be done for the day. Okay, so again, we're starting off at negative 6, negative 7, and then I want to go up 1, so negative 5, and then negative 7, and then I want to go, what was it again, 1 cubed, 1, 2 cubed, 8, so I want to go up 8 from my original value, which is 2. And then this one is going to be negative 14, which I don't need to do. So 2. Plug in 2. 2 plus 6 is 8. Cube root of 8 is 2. 2 minus 7 is negative 5. Negative 5 plus 6 is 1. Cube root of 1 is 1. 1 minus 7 is negative 6. And then, yeah. Plug in 7, get negative 8. Plug in, negative, oh yeah, negative 4. If I were to do negative 14, it would be negative 14 plus 6, which is negative 8. Cube root of negative 8 is negative 2. Negative 2 minus 7 is negative 9. So, this is what it looks like. 2. negative 5. And then negative 5, negative 6, all the way over here. Negative 5, negative 6, negative 6, negative 7, negative 7, boom, boom, boom. So this is where it curves like that. And that's where it down curves like that. Alright. Have a good day.